So we're going to do shorthand notation. So the first thing that we did with the arrows, we can't draw arrows for every single electron configuration that we do, but they are important because every electron within an element participates in going from ground state to excited state and back in that production of light, okay? And those discrete energy levels that each electron jumps produces a specific wavelength. So every electron is important for light production, yes. Now, in bonding, which electrons in an atom participate in bonding? Do all of them participate? Does every arrow in those diagrams, do those participate in a chemical reaction? And the answer is no, okay? Those are important when we're talking about light production, but in a typical chemical reaction, only the valence electrons participate in bonding. So sometimes we want to look at just an element's valence electrons, okay? And so we don't want to draw out a whole electron configuration. We want a shorthand for this. And so we use something called noble gas shorthand, okay? Obviously, it has to have something to do with noble gases. And we know noble gases are group 18, neon, argon, krypton, xenon, radon. Also helium, which has been moved over here on this periodic table just to show its number of electrons, okay? All of those are noble gases. We know noble gases don't react, okay? So their electron configurations are always going to be the same. They're very, very reliable. So we can use a noble gas as a placeholder for electrons in an electron configuration. For example, chlorine. It's atomic number 17, right? So, which noble gas is a little bit smaller than chlorine? Neon, right? So, I can, whenever I'm doing its shorthand, I can say neon is a placeholder for the first 10 electrons in chlorine. Why? Because neon always has those 10 electrons in the same order every time, okay? And then I do my electron configuration from there like I normally would. So, neon, 3s2, 3p5. Now, how many valence electrons does chlorine have? Well, 2 plus 5 makes 7. Chlorine has 7 valence electrons. That's what really matters in a chemical reaction, okay? Let's do the same thing for bromine. Bromine. Argon is smaller than bromine. And then we count from there. 4s2, 3d10, 4p5. How many valence electrons does bromine have? At first glance, you want to say it has 17. 2 plus 10 plus 5. But notice this 3d. 3d means the third energy level. So that's not a valence electrons. Those 10 are not valence. It's really these 2 plus those 5. So bromine only has 7 valence electrons, okay? Just like chlorine. Well, does that make sense? Well, they're in the same group on the periodic table. So yes, that makes sense, okay? So this is an awesome shortcut for when we just really care about the outermost electrons within an atom.